All right, hey everyone. Thank you guys for being here. We are Anthias Labs. I'm Charlie, and we're going to speak on our open source command line interface that we did for Solana with the Solana Foundation called Flare. So a bit of background on Anthias Labs for those of you who might not know us. We are a boutique risk firm. So we tackle what we deem mission critical issues and just general risk management work for a select few protocol partners, primarily in stealth. And so, now our research engineer, Nico, is going to fill a bit in on Flare and walk through a little demo.
Okay. All right, so basically Flare is a CLI we built, which is meant to empower developers to quickly test and iterate over different programs on the Solana chain. So the idea is to make actual contract interactions as easy as possible. So let's go through a simple example to show what we mean. So for this example, we're going to be using the on-chain voting example from Anchor by Example. So it's essentially a program that stores a vote count, which can be either good morning or good night. So each vote count has just one number for good morning and one number for good night. So the first step would be to actually fetch the IDL. So you can imagine maybe you want to see what the program does. So first step is actually fetching the IDL, which you can do with Flare, and it just returns the JSON here. From here, you can see there's a couple instructions. The first one would be init vote bank. So now you want to init vote bank. You can check directly on the IDL what the accounts required are. There's no arguments. So then you might want to create the actual account. Again, you can just do it with Flare. You just run Flare wallet create, and it returns the address of the vote account, the mnemonic, and it stores the actual key pair to a JSON file. Next up, this is kind of like the meat of Flare, which is actually running the init vote bank instruction. So normally you would require to do this from either TypeScript and just using the Anchor library, or if you actually have the source code of the program, you can just do it from Rust, and you can generate the crate for it. But the problem with that is, first, you need the source code, and second, if you want to use TypeScript, you have to need the whole npm package and download a couple hundred megabytes and requires Node and everything. So this is kind of like an easier and faster way of doing it. You can just run Flare. You can specify what cluster you want to run in it. So right now it's DevNet. You can also do, obviously, mainnet, testnet, or even just any RPC URL. So if you're running, for example, a local chain, you can just use that. And then we want to run the call subcommand. You pass it the program address, the key pair for the signer, so just who's sending the transaction. You can pass it an IDL. If you don't have the IDL, Flare will actually automatically download the IDL, so this is not strictly necessary. Then you can specify what accounts you want to run for the instruction. So this is the vote account we just created, so the actual vote bank. You can also pass it your wallet address and the system program. Then you specify who are the signers for the transaction and the actual name of the instruction, which is init vote bank. Apart from doing this, there's also the option to just write kind of like a simple JSON file with the accounts, just to make the syntax a bit easier. But you can see how this is a single CLI command that allows us to run this kind of complex instruction straight from our terminal. So after that, we actually want to vote. So you can imagine maybe this is not even your vote bank. This is just something someone else created. And you can run, again, the call subcommand. You pass it your key pair, the actual program address. The accounts will be the vote bank and your wallet address. And, well, again, the IDL is actually optional. And we want to call the give vote command with good morning. And after calling that, you might want to check what's the current state of the vote bank. So Flare also allows automatic deserialization of accounts. So this is kind of interesting because, for example, the Anchor CLI requires you actually say the name of the program and the structure of the account you're reading. With Flare, it's not necessary. It can automatically infer the data type from the discriminator in the account. So essentially, all the accounts with data have a small number that specifies what it is. So yeah, that kind of simplifies the command a lot. And again, you can pass it the IDL if you have it downloaded, but it's not necessary. And it will just return JSON with the actual state of the account. So yeah, now let's actually say what you can use Flare for. So obviously, we're trying to build it as versatile as possible. But kind of magic of Flare is that it's a single binary. It's about 10 megabytes. And you can run it on basically any platform. So a first use case might be actually building server jobs with it. So maybe you want to run a certain instruction or read some value from the blockchain on a server, but you don't want to either do a full node installation and a couple hundred megabytes of NPM packages to build a TypeScript script for that, or you don't want to build an actual Rust program for it because maybe you don't have the source code for the program. So you can just use Flare to either read or write to the program, and you don't need to add more bloat to it. A second use case might be, for example, exploring different programs. So maybe there's a couple of programs you're not too sure about that you want to integrate either with your program or another type of decentralized application. And again, Flare allows you to kind of easily explore them, download the IDL, call some commands, read some accounts, and do that kind of fast iteration with that. A third use case might be actually testing your own program. Obviously, you might want to do actual tests in a nice TypeScript script or whatever, but sometimes you just want to run a single command and see what it does. So this is an easier way to do it. You can just plop it into your command line and it will run. And finally, you might want to write some simple scripts with Flare. So maybe you want a bash script to update something. You want to interact with the blockchain, but you don't want to write your own program for your program or a contract. And Flare is just an easier alternative. You can just call the Flare command from any bash script, and it will work. So some actually examples with that. This is a bash script we wrote. We are using the self-custodial Facebook example, which is just an example where you can create your own Facebook account with the status and a name and such. And it requires a PDA, so a program derived address. Flare allows you to actually derive the address automatically with the generate PDA subcommand. So for example, this script allows you to just pass it a random account from a wallet, and it will generate the PDA for its Facebook account and then read the actual account. So yeah, we first generate the PDA with Flare. We grab the first line to avoid the bump, and we pass that to the Flare read account command with our program and the Facebook address we derived here, and it will just return a JSON with the actual state of the Facebook account. And yeah, a second example would be, for example, with our real world program. Here we are interacting with Drift, and we might want to grab some prices from Drift. For example, we want to know the current pair price of Sol on Drift. Yeah, you could write, again, you could do a whole API for it. You can write TypeScript, whatever, but you might want to do something easier, and this is such an example. So first we have this JSON file, which is just the perp addresses for the accounts. You can just grab that manually. So in this example, for example, we want to pass it a certain ticker. It will search for that ticker in the JSON file. This is just a bash utility. And then we can just read the account using Flare that we gave it. You pass it the IDL if you want, just to make it a bit quicker so it doesn't have to re-download it every time. And then, yeah, JQ is just a JSON querying tool. So yeah, for example, here we could just write this to a file, and if we call, sorry, I'm blocking it, but you can just call drift price fetch with the ticker, and it will return the price. That's actually on chain. And another kind of interesting use case for Flare is that you could actually interface from basically any programming language. So, for example, Python does have an Anchor Py client that you might use, but imagine it didn't or you don't want to deal with it. You can just open a shell and run the command. This is 3 lines, which allows you to integrate Flare into a Python file. Obviously, this is not safe. Please don't do this for any user-facing program. This is very easily injectable, but imagine this is your own script that you're just going to run yourself, or you have some sanitization before. Yeah, you can just write this simple function, and then, again, we load the drift addresses. And in this example, for example, we go through each token and then call the Flare read account command. And this builds out this kind of nice markdown table with all the current prices. So you can imagine, for example, having this on a personal server if you want an updated list of prices, and you just run it and it provides the actual list. So yeah, finally, we are an open source project, so we are always looking forward for new contributors. So if you're interested in that, please make sure to check out our GitHub. If you don't want to scan it, it's github.com/Anthias-labs/Flare. And also, if you're building on Solana, we would love to actually hear your thoughts about it, so do give it a try. We have binaries built for Windows, Linux, and Mac, so pretty much everyone. And yeah, I think that's it on our side.
That's about it. Thank you.